Hello everyone, welcome back to my channel. I am Kostal Datta, USN 1VE23 CS082, semester 2nd, section BMW. So today's video is going to be on the subject Computer Aided Engineering Drawing bearing the subject code BCEDK203. So let's have a quick introduction about CAD or engineering drawing. Engineering drawing is a handy tool of communication used by the people associated with the design, manufacture and use of any product of technology. Examples: automobile, airplane, building structure, bridge, ship, machine, etc. Engineering drawing is a two-dimensional graphic representation of the various three-dimensional physical components used in the product. Engineering drawing contains all the requisite information pertaining to the components such as true geometrical size, shape, materials of construction, sequence of processing or machining, sequence of assembly, procedure for usage, etc. Basics of CAD. So let's talk about the principal planes of projection. So basically there are three planes of projection: HP, VP, PP, namely horizontal plane, vertical plane and profile plane. This will be used when we are drawing on the sheet or in solid edge. So basically HP is the plane which is horizontal to the surface and VP is the plane which is vertical to the surface. And the line which is connecting both the planes is called the XY line. Quadrant system. When the HP and VP are chosen together as reference planes, the whole three-dimensional space is divided into four distinct regions called quadrants. The first quadrant region, it is the whole region in front of the vertical plane and above horizontal plane. Two quadrant region, it is the whole region behind the vertical plane and above horizontal plane. Three quadrant region, it is the whole region behind the vertical plane and below the horizontal plane. And the last four quadrant region, it is the whole region in front of vertical plane and below the horizontal plane. So basically the quadrant system is same as that in coordinate system. The first quadrant is the one which is having the above HP and in front of VP. Second quadrant is above HP and behind VP. Third quadrant is below HP and behind VP, and fourth quadrant is below HP in front of VP. So the notations, following notations should be followed while naming different views in orthographic projection. So when we are drawing on CAD in solid edge or in grid sheet, we should remember the three notations. For top view, we write a line as A with AB or a point as A. In front view, we use a single dash to represent the point in front view, and in line it is A dash B dash, and in side view it is represented as double dash, namely in point A double dash and in line A double dash B double dash. So now I am going to solve these two problems in solid edge. I am going to show how to do this in solid edge. Okay, so this is the first question. Let's solve this. So the question says that a line AB 80 mm long has its end A 20 mm above HP and 30 mm in front of VP. It is inclined at 30 degree to HP and 45 degree to VP. Draw the projections of the line and find apparent lengths and apparent inclinations. So first let us draw one XY line. We change the thickness to 0.35 mm. Now I am drawing the line. Yeah. So this is our XY line. Just name this X, Y. The upper half is VP. The lower half is HP. Okay. So now it is given that the end A 20 mm above HP and 30 mm in front of VP. So above HP means the line will be, let us select the offset option, then change thickness to 0.35 mm only. Now select this line and in the distance section write 20. Yeah, this is the 20 mm line above HP, and again select offset, select this line into 30. So this is the 30 mm line in front of VP. Done. Now I will select the line and change the thickness to 0.50 mm and draw a reference line. Okay. Let us name this line as A dash, A dash and A, and name this line as locus of E dash, and this as locus of B dash of A. Okay. Now it is given that a line AB 80 mm long and is in 20 mm above HP. We have done that. 30 mm in front of VP. We have drawn two locuses. Now it is given that it is inclined at 30 degree to HP and 45 degree to VP. So 30 degree to HP means we need to draw the line 30 degree inclined here, and 45 degree to VP means we need to draw the line here. So opposite sides. Okay. So now I am drawing a line. Now I am drawing the line 30 degree to HP and the length should be 80 mm. So 80, and at angle I am giving it as 30. Okay, now put it here. Sorry. Putting it here, then length as 80 and angle as 30. Okay. So first condition is satisfied. It is inclined at 30 to HP. 30 to HP. Now 45 degree to VP. 45 degree to VP means we need to draw this line from here. Selecting this line. Now I will write 80, and at angle I will give minus 45. Why minus 45? Because it is in fourth quadrant, right? This line is in fourth quadrant. This is first quadrant, this is second quadrant, this is third quadrant, and this is fourth quadrant. So as the line is in fourth quadrant, I will give angle as minus 45. Minus 45. Okay. Now I will draw two locuses from these two lines. So first I will bring the cursor to this end and then I will shift it. So you can see a dotted line. This is coming through this option, alignment indicator. You need to turn on this. If it's not coming, then it will just give a straight line to indicate, as the name suggests, it indicates an alignment. Now I am drawing this line. We will go from the top only. Let us first change the thickness to 0.35 mm. Right, it's done. Now same we will change the thickness to 0.35 only and draw one locus here also. Here. Now what will I do is, uh, first let us take it little bit upwards because it is very much in the downside. Okay. Now I am selecting the line option again and I will change the thickness to 0.13 mm and I will project this line downwards. Acha, first name this line, name these points. Okay. So as this is the original line, so I will name this as B1 dash and I will name this as B1. Okay. Now I'm selecting the line thickness as 0.13 mm. Now I will bring the cursor here and draw a straight line to locus of A. Okay. And again I will take from this line and will draw it, draw a straight line up to the locus of A dash. Done. Now what we need to do is we will select this option arc by center point. Now we will put this point at A up to B1 dash, this straight line from B1 dash. Take this point and cut an arc. Same, we'll take this point A1 A dash up to the projection from B1 and then take this point and cut an arc on this locus. Okay, right? Now what will we do? We will name this two locuses. We'll name this as locus of B1 dash and this as locus of B1. Okay. Now what we will do is change the thickness to 0.50. Now we'll connect a line from this line into zoom it. For zooming we can use zoom area option, then just drag it here, it will zoom. Okay, so we have zoomed it. Now we will take the line option 0.50, it's there only, and now we will find this center point on this red point and I will fit the page and connect it to this line. So this is our first apparent length and same goes here also. We will take this point and draw it up to here, the second apparent length. Okay. Now we will name these points as B dash and B. Okay. We can also join this line. We can make the projector. This line is called projector. So select 0.35 mm. Now from here We'll draw one line. This is the projector line. We'll do the same. Actually this will not be 0.5 mm, it will be 0.35 only, this line also. So yeah, these are the two projectors, and our drawing is complete. Now we will show the leader, we will show the arrows using the leader option. So we have drawn this line first, now it's going like this, so we will put the arrow here, and one arrow from here to this one. Similarly we will show another arrow from this line to here. Okay, so the projection is complete. Now what we will do is we will find the projection angles. So the original angle for this one is, as you have given, 30°, and this one is 45°. Okay, now we will find the apparent inclinations. So this is the apparent inclination of the first one, and this is the apparent inclination of the second one. Okay, and now the apparent lengths. So the first apparent length is this one, second one is this. Okay, similarly we will show the distance between these two lines. Okay, and also the length of this line. And this line. So this question is done. Now we will write the length and inclination we found. So we copy this alpha and beta symbol from here. Now I will paste it here. Let's write the angle as A and B only. A equals to 45°, B equals to 55, A dash B dash equals to 56.55, and AB equals to 68.91. This question is complete. Okay, so now we will do the second problem. For this, what we will do is first we make a xy line. So this is the xy line. Let's name it as x, y. Similarly, this is VP, this is HP. Okay, so now what the question says is an equilateral triangular lamina of 25 mm side lies on one of its edges on HP such that the surface of the lamina is inclined to HP at 60 degree. The edge on which it rests is inclined to VP at 60 degree. The projections. So this is edge condition. One of its edge on VP, HP. So first of all we will draw a triangle with 25 mm sides. Now set the line, change it to 50 mm. Now I am drawing 25 mm, angle is 0 degree. Now again 25 mm, and the angle should be, as you know, equilateral triangle has 60 degree angle in all sides, but I need to draw this line in the second quadrant, so the angle should be 120. So 120. Then we will just simply join this here. From this corner to this corner. Now triangle is ready. So now we need to rotate it because it's given that the edge lies with one of its edge on HP. So we need to bring this edge. So what we'll do is first of all move this triangle to here. Better should be better it should be here. So the triangle lies here. I will rotate the triangle from here to here. Okay. We will select this line, this triangle. Now we will move it upwards. Okay. Now I will choose the rotate option. I will select it from here to here, and then I will first shut this copy or option. Now this line appears, means it is at exact 90 degree. Now done. And again I will move the triangle here. Right? So now the first condition is satisfied. The triangle lies on one of its edge on HP. Now we will draw projections. So for that I select the line and select 0.13 mm. From this line I need to draw it to XY line. Similarly from this line to XY line. Okay. Now name the corners. This is A, this is B, and this one is C. And similarly this edge will be B dash, A dash. A dash will be in bracket because A dash is not visible. So this will be C dash. Okay. We will make this line thick from here to here. It's thick. Okay. Now what we will do is we select this thick line along with the naming selected. Now I will move it and I will turn on this copy option. I will move it from this edge only, put it here. Then I will rotate this. So how much is the angle given is inclined to HP at 60 degrees. So we need to draw it to 60 degrees. 60. Okay. Now I will draw projections downward. This 0.13 mm. This one from here to this. Okay. Similarly, projections from here to this one, here to this, here to this. Now I will draw the second view. This I will first select 0.50 mm. Now from here alright, so this is the second view. I will name the second view also as A, B and C. And I will show the angle as this one, 60 degree. Okay. Now I will draw a XY line. Sorry, I will draw a line for reference having 60 degree with HP. So length, let it be anything, arbitrary length. This one minus 60. So this is the reference line. Now what will I do is I will select this line, this triangle, and then I will move it from here to there, and I will rotate from this point to this point. Okay, it's done. Now what we'll do is we will project it upwards in the VP. So this is to 0.13, right? A to A is here only, so up to here. B is also here. And C is Now I will draw the triangle. So the thickness to 0.50 mm. Now join these points from here to here to here, then again here. Sorry, from this point to here. Okay. Now I will name the points. So this one is A dash, this one is B dash, this one is C dash. Okay, and also the angle between these lines. So the angle is 60. Now we will show the arrows. So select the leader option and then show the arrows from here to there. So all the arrows are shown, and similarly from here to here. Okay, if we want we can join these lines also. So select 0.13, done. Similarly show the leader from here to there. This question is also completed. So that's all with the questions. So as you can see, we have completed both the questions, and now I would like to end this video. So if you found this video helpful, then please like, share and subscribe to my channel for more such contents. Thank you.